Sorry, I opened the lab. Let me get to the notes. Okay, so today we're going to talk a little bit more about TCP/IP utility, mostly working with this utility in command prompt or command line. These are really useful tools that you are going to be applying in the networking troubleshooting to be able to also apply in the cybersecurity area, especially also in configuring your system or monitoring your system. So at the beginning, it goes over ARP, which is Address Resolution Protocol. This is very important. As I mentioned before, you can also look into ARP poisoning, but we want to be able to look at the information that's stored, that's cached with ARP. And we've done ipconfig before, where we looked at IP addresses. Now, this particular command it's retired, right? We don't use ifconfig anymore in Linux systems. Now we just use IP space address to be able to look at your IP configuration for your interface. So if we open up command prompt, type in CMD on your search bar like this. And you can go through. So if you don't know a command, let's, for example, like ARP, like this, I can try to do the H or the help option, right? So if I type in ARP-H like this, it's gonna give me the options or the switch that's following my command. This is how you can access help menu or help options for a command. So if I'm doing address resolution protocol, this is a way it says that it is able to show, right, your local cache address resolution protocol. So if you want to display everything, we can do, let me change my pop-up a little bit. Give me a second. I can do ARP-space-A like that. And it would show the history for my interface or what's stored, right? As far as my IP address that's associated with my MAC address. That's what ARP does. It's able to pinpoint the system, right, from a network standpoint and also from a data link layer. And when you see FFF like this in your physical or your MAC address, that is a broadcast. And you can see that's a broadcast IP right there. Right? We talked about that last time. So you see the MAC address here. That's your hexadecimal value. And then your decimal value in IP. Yours is going to be slightly different. It might be less. It depends on how you connect to the network. Okay, I'm just, oh, is it CLR? Oh, maybe not. Okay, next we can do, you already know ipconfig, right? When you do ipconfig, it's going to give you configuration for the address. So we can see our physical, our IP address, our subnet mask. Now, if you do ipconfig space/all, that's going to give you everything versus regular ipconfig, right? And you notice that I have other interfaces like my virtual machine interface, my wireless, right? And then host only, so you might have other interface. So right now I'm on wireless, so it gives me that. Yours is going to be a little different. Okay, so let's go through and answer some questions. We are going to go through and identify the utility for the appropriate scenario. Number 1, A. Jessica wants to display and modify ARP cache on the system. Which utility should she use? She should use ARP or ARP. And the switch or the option that's used with ARP command is going to be -A. So when you do -A, that's all. It's going to give you all the cache information or what's stored for ARP. Now, if I want to input or set a value or set some information into the cache, I can use ARP-S. So like I said before, right? If you don't know what option or switch to use after the command, you would use the -H as help, or you can use /help, and that's going to give you the option. And ARP table is going to give you what? The IP address that's associated with the MAC address. That's how it's going to be able to pinpoint which system, right, that is on the actual segment. For B, the network administrator wants to gather the statistic of the system current TCP IP connections, right? We want to see if that's an active connection or a stale connection. So when we say a stale connection, that just means that it is historically there, but it's no longer being reused. So your system stored the connectivity because in the case, let's say that I go to work, I connect to that network, and then I go home. Tomorrow I would do the same thing. So, or sometime in the day, I might disconnect from that particular network and go to lunch. And then when I come back from lunch wirelessly, I'm going to connect again. So it cached that information to reestablish the connectivity so that way it doesn't have to reconnect every single time. So netstat is going to give you statistic information, right, of your current connection. And if it's all historically there, it also shows it, but it's going to show it as stale connection. Okay. And we can try that. You might have to be an administrator on your system for this. So if we say netstat like this, right? It's going to take a few seconds for it to go through. So it's going to give you active connection. Okay. And as you can see, it started to pop up, right? It's showing me that I'm connected to a website, right? Possibly with Zoom or Canvas, and it's through a certain port. And then it tells me the state established. So you're going to see some traffic that's HTTPS like this, and then you might see some traffic that's not, depending on what you're connecting to. And you can try that on your system. It really depends on the system and what's being connected. So if you're connecting to many different websites, it's going to show this, right? So it shows that I have established a connection.
Not a way just to overall see the overall history of the searches and connection.
It's mostly just for connection. So if you wanted, and it will present to you the active connections. So when you see close wait like this, right, possibly that it's timing out, or maybe it doesn't communicate, and it's also ended the sessions, or depending on the activity of that system and the user also, right? So this is a good way to kind of see, if you troubleshooting connectivity, or even if you're looking at applications that's using network-based services, it's also good to see netstat, right? And then when you look at this one, time wait. So sometimes the server would time out, as, you know, maybe it's not responding, or maybe, you know, that session has ended. So you do see the state of that changing. Okay. And then close wait. So there's time wait that it's still pending the response, and then the close wait is ending. Like this. Okay. So that's mostly for administration purposes, and it's gonna keep going for a while, right? And then it's gonna give you some information. I have some loopback right here. Right, I'm connecting to myself for some service. Okay, so we saw the net stat. And then you can ping. So for C, Jose is trying to verify host IP and physical connection of his computer to see if that system is connected. Which utility should he use? And so he can use ping, and we can do an IP address as the destination for that. We can also ping a loopback address. So you can do ping and an actual address like 10.31.0.183, or you can ping a loopback, which is like this. 127.0.0.1. So it's gonna ping the host itself. An example of an IP address will be like this: ping 10.0.8.138, for example, like that. So you always want to follow the ping with a destination address, right? So if you can ping yourself using a loopback address, you can also ping the computer IP address. So when you ping, you should be able to see whether it gets a response. So if it's connected, it's using ICMP, right? It's going to send out 4 requests, and then it's going to receive a certain number of reply. If it doesn't get any reply, then that means that there's disconnection of the system. For D, it says a technician needs to troubleshoot a conflict of net BIOS of 2 systems on the network. Possibly there's a conflict with names. Maybe both of them are getting renamed, or one of them getting renamed and they have the same name. Which utility should the technician use? So you can use NBT stat and host name. So because this is net BIOS, it's going to refer to the host name. So when I say the host name, that's the computer name. So anyone know how to find the host name? Host name. Right? You can try it out on your computer, type in the host name, right? So earlier we talked about ping. You've seen this, we tried this several times. So we can ping a loopback address. And if it's replying, right, in Windows, it's going to ask 4 times, are you there, are you there, are you there? And it's going to reply 4 times. That means it's 100% successful. But if it shows timeout, that means that it's not successful, right? It's unsuccessful. And then if you want to use the NBT stat, right? And then you just got to put in your host name information. Okay. For E, it says Christina is looking to connect remotely to the system's terminal for troubleshooting. We don't really use Telnet anymore, but Telnet can be used because Telnet is not secure. That means that if someone is using Telnet, it's going to show everything in plain text. It's not encrypted. right? It's not secure, as in the traffic is not encrypted. So if you're using Telnet, if Christina is using Telnet, can I spy on her? Sure. I can simply run a Wireshark scan or a sniffer on that particular network, and I should be able to see her traffic. And anytime that you are using unencrypted traffic, guess what happens? When you log in an unencrypted traffic, Wireshark can pick that up, right? Your sniffer can see password in plain text, right? Because it comes in as a payload, as data with that packet. So Telnet is not secure in the aspect that it doesn't have security with the traffic, right? This is used in an older system, very weak in security. For remote access, we should use RDP on Windows PC and SSH on Linux system. So in place of Telnet, we should use Secure Shell or Remote Desktop Protocol. Okay. Any question regarding the utility? So make sure we know how to use these utility. We will use some of these in our lab today using command prompt, and then a little bit on the PowerShell side. So in Linux and Windows, hostname is the same. So if you're not sure on what your computer name is, just type in hostname as one word, right? On Windows command prompt, it should be able to give you your computer name. And on Linux system, it's also should be able to give you your system name as well. Any question? Okay. So here it gives you the breakdown of the functionality of each of the protocol or each of the utility, like ARP as a protocol. So when you're looking at ARP messages, you're going to get requests and reply. And then they have the RARP. Okay, request and the reply. So earlier, as I mentioned, that you can do the set ARP, right, -S. That's a static entry. You can input that into the actual storage. You can set an entry, and that's considered static. And a lot of this information, you can also look into the registry of the Windows. So it's going to show you the parameters, right? So ARP with the R in the front, which is RARP, this is reverse ARP. So we says that ARP is going to translate IP to MAC address. The RARP is reverse. It's going to be MAC address to IP. Okay. Think of it like, you know how you're identified to your social security number, right? Your name is to your social security number. That's what we give to identify ourselves all the time. In reverse of that, every time that I pull up your social security number, I would be able to know that's you, right? So reverse ARP is the same way. We can look at the MAC address and say, oh, that's associated with this IP that belongs to the system. Okay. ipconfig. So one thing that I want you to remember, and I know many of you know this, but when it comes to troubleshooting, so for example, someone tells you that they don't have connection to the network, they don't have internet access, and then you open up the command prompt and you do ipconfig, and you see an IP address, right? For some reason. But let's say that maybe something's wrong with the way that the IP is released. So let's get rid of that IP. Let's flush it. Okay. So you can do ipconfig /release. And what that will do is it's going to remove that assigned IP address, and then you're gonna follow it up with the renew, okay? So when you do that, it's gonna get rid of the old IP address that the server has given it. And then when you do the renew, it's gonna obtain another IP. But wait, sometimes it's gonna get the same IP address because that's the available one, right? Let's think about it, right? Let's say that you're given an IP address and you give it back. You say, I don't need it anymore, get rid of it. You give it back, the server still has an IP address, and then a second later, you're like, oh wait, I need an IP address. So the server is gonna say, okay, here's the same IP address that you have, right? And then sometime the server is configured to release you the same IP address for 90 days. So because the 90 days is not up yet, we saw that configuration in one of the lab before, it's gonna give you the same IP address again, right? So a way that we can troubleshoot with connectivity is that let's flush out the IP address that's given and let's get a new one. See if that works, right? And a lot of times it does, okay? So in Linux, you can also renew it with the DH client, depending on the release of the Linux, right? They have a new suite now with the IP address to find the IP address configuration. So they had retired some of the old commands in Debian. Okay. Also for DNS, okay. Sometime when you're trying to connect to the network and it tells you that the DNS that you're connecting to is no longer available. Have you seen that before? It says that you don't have access to this domain anymore. So what you need to do is you need to get rid of that because it's stored onto the memory and it's referring to that and it's preventing that system to be connecting to another domain. So what you need to do is you need to resolve it. You need to do a flush DNS, right? So you would use the same command, but following up with the space and the /flush DNS. And then after that, because ultimately in ipconfig, it's going to tell you what domain that you're connecting to, right? What network you're connecting to. So it's going to resolve that and store that onto the cache. Okay. So you're going to flush it and then you can display it again to see. Okay. Okay. Let's go back to our assignment. Okay, so for number 2, it says, when does ARP broadcast occur? Right? Address resolution protocol, how we associate the IP address to the MAC. So when you have a system that the IP and the MAC address entry is not stored, then it's because what happens is in that segment, it's going to identify the system based on the IP that's associated with the MAC address. But if it's not stored, then it's not going to be able to identify that system. So what will happen is it's going to then end up broadcasting. Meaning that, let's think about it, right? Let's say that you have a group of kids, right? You give each kid a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then there's one kid that didn't have a number, right? Or there's one kid that didn't have a name. So what will happen is it's gonna say out loud to all the other systems, it's gonna say, who is this, right? Which system is this? Because it doesn't have that in the table to really identify physically where that computer is. So you are gonna have an ARP broadcast. Now, can you see an attack standpoint from this aspect, right? Can I broadcast this to the segment and be able to identify the system or identify myself as a system onto the segment? So from an attacker standpoint, they are going to use a way that the system is a process that's used by the system to be able to either get themselves into a certain area of the network or be recognized in that certain area of the network, right? So ARP can be used in many different forms from an attack standpoint. So as you understand that, yeah, there are times that it's going to broadcast because it's not able to recognize, it's not listed onto its table, right? And then, but most of the time we want that information is stored. But if someone can access that stored information and modify it, because you know you can set an entry. So if someone can access your ARP table and modify it, it becomes an ARP poison, right? Because you saw when you pull that up, you see, right, how it's associating your system to the next. If I'm spoofing your address, I better be able to have a record that I am you, right? It's kind of like I'm faking your identity. I have to make sure that I am associated with your social security number. So to really reduce, so this, why does the system store ARP information as cache? It's really a way for it to reduce the bandwidth use. If you broadcast a lot, it's going to take up a lot of your bandwidth and resources, right? More just to identify who that is. So just imagine if you're in a crowded place, and if you have to identify every single person on a loudspeaker saying, who is this with this social security number, right? That's going to take you a long time to go through and identify 50 people. Versus if I have a list that's associated a name with a social security number, I already know who's who, right? So to really reduce the broadcast of the address resolution and also the network usage, ultimately your bandwidth, it needs to be able to store it. But we have to consider how we protect the cache information is really important, because if someone, right, jeopardize the integrity of your ARP table, then they can have ARP poison. That's how it works. Any question? Okay. So you can refer to the notes in the ARP section, ARP, and you should be able to see. So the lifetime of ARP cache entry in Windows system, and we're only looking at Windows system, it's going to be about 2 minutes. Within that 2 minutes, if it's being reused, that means that if the connection is being reestablished, bless you, then it stays on that ARP table for 10 minutes. Right? So if I'm connecting to the same website or the same network or some various systems inside my network, then my ARP table, right, have some same entry that's getting refreshed and it stays longer. The entry that gets stale, it gets stale after 2 minutes, it's gonna flush that out. Eventually, right, it's gonna reuse that space to store new entry. But what if I have an isolated system that's not connecting to nobody and no network? There's nothing to be established, right? No connection updated. So if I, let's say, isolate that system and disconnect it, after a period of time, 2 minutes or sometimes 10 minutes, everything gets flushed. So in some cases, when you're looking at ARP table, it's more or less, right? So if I'm connecting to, you know, a lot of different websites and many different servers via the network, I'm going to have a longer table. And as I constantly do that for somebody who's active and the system is communicating back and forth, my table retains. But if that gets disconnected and it no longer is on the network, then that table gets flushed, right? And then we touch on the difference between reverse ARP and ARP. Reverse ARP translate MAC address to IP. Physical system to an IP address that's given on the network, right? Because ultimately it needs to bring it to that system, but from a physical address to the network address. And ARP translate network address to a physical address. So you always see these two go hand in hand. Why? Using ARP, because we need to really narrow down which system is communicating. Without ARP, you can't. Right? Network address translation protocol, which is NAT, is public IP to private IP, where ARP is MAC to IP and IP to MAC. Any question? Okay, we talked about number 6. What commands do you use to remove an assigned IP address from a system and obtain a new IP address from the DHCP server? So most of you already done the lab for DHCP server where you configure it, you create a scope to assign IP version 4 and version 6 addresses, right? So if I have a computer that's connecting to that network, that the server is going to be able to release or give me an IP. So on the system, on the computer, let's say a laptop or a desktop, if you want to get rid of the assigned IP, you would use ipconfig /release. This is going to remove the assigned IP address. And then shortly after that, I want to renew ipconfig /renew. That's going to obtain a new IP address from the server. But you can also get around it by rebooting your computer, right? Sound cliche, and whenever you call tech support, they're going to say, hey, why don't you restart your computer, right? So in the restart process, when you reboot, your connectivity is being reestablished, okay? Your interface, your Ethernet adapter or your wireless is going to try to detect, right, what it's connecting to. So if I'm connecting via an Ethernet cable, it's going to send a signal, right, to the switch. It's going to say, hey, I want to connect, right? Or if I'm on the wireless network, it's going to then try to reconnect if you save that SSID and login information or your password, right? Or your passphrase for that wireless network. It's going to try to reestablish. So in that sense, when you are rebooting your computer, you're releasing and renewing your IP address in the steps of rebooting your computer, right? So if I release and renew and that's not working, my next suggestion for you is have it rebooted. Okay. And then if that doesn't work, try to also look at other things, right? Like ping it. If it has an IP address, ping it. Question. Okay. Let me take this down. So the command that's used to renew an IP address in the Linux system is going to be dhclient. But again, if you don't remember the command, what do? Reboot. Okay. In terminal, that's what you do. Just restart it, reboot. And with that, it's going to try to reestablish the connection, obtain an IP address. And if that's the same available IP address, it's the same IP. But if it's not, right, it might be a different IP. So to view the DNS resolver cache information, you would then refer to ipconfig /DNS, display DNS. That's going to give you DNS information. Is there another way that I can look up my domain? Anyone know? YouTube 27. You should know this. So how can I look up what domain I'm connecting to without using that? How can I look up the hints is in the question? How do I look up what domain am I looking up? I'm connecting to using command prompt. Anyone know about nslookup?
I was gonna say DNS.
Oh, come on, you guys. You took 27 and the other classes. We should know this. We should know it like the back of our hands, right? Okay, so there are many ways to do things if one command doesn't work, but this way it's going to give you the DNS display information or the stored DNS information. And if you want to get rid of the stored information, you would do a flush DNS. This is done sometime when it tells you that it cannot resolve. Like, for example, I open up my browser and I try to go to google.com and it tells me what? DNS cannot be resolved, right? Domain is unavailable. So I know that it has something to do with my configuration for my connection. So I would try to look up if I have an IP address. If I don't have an IP address, that means that my interface is not seeing the network. Maybe my cable's disconnected or I'm not connecting on the wireless side. So you always want to troubleshoot through the layers, like what I mentioned before, okay? Check the physical connection and then go through and see if you have, MAC addresses, IP addresses, and so on. And then start it to navigate all the way through how we will connect to the network. Is it obtaining an IP address and so on? Okay, since we talk about that, let's try it. nslookup, one word. Right? It tells me, what's this address right here? DNS server, okay? So if you want to know what domain, what network that you're connecting to, do nslookup. But wait, it doesn't have the same pop-up. You say, how do I get out? Control C or exit, I'm sorry. Is it exit? Yep, exit. So when you in nslookup, it takes you into the command line interface for nslookup, and then you have to do exit to get back to your pop-up. Okay? All right. Okay. So when you're using ping utility, we touched on protocol in the prior weeks. What protocol is used by ping? And ping, we can use it to verify remote connections for hosts. Like I can ping a web server, I can ping another computer that's next to me. I can ping any system that is alive. I would get a result in reply. But if I ping a system that's not connected, then it will show timeout, right? My request would not be replied. So when you're looking at ICMP, and this is for version 4, we touched on this in the prior week. When you do ICMP, it's gonna have ICMP request and ICMP reply. So if I ping the destination system, the target system, I am sending the request to that system. Hey, are you there? It's like saying, hey, are you there, right? To the system. Is system 10.5.0.38 there? And then the system would receive my request and it's going to say, yes, I'm here. So it's going to reply to my packet. Okay. So it's going to send a packet back in a reply. And with that, it's going to do an ICMP reply. Now, if you're doing a version 6 ping, it needs to use the ICMP v6, right? So we would ping the same thing, but the address is then using what the version 6 addresses, your hexadecimal addresses that we talked about in the prior session. Okay. So all you have to do is ping and then the addresses following the ping command. Now, the command, the option, the switch that you would use is the -A. This is used to resolve an IP to a host name. So if I don't know what switch to use, I can use ping help, right? Ping -H is going to give you the options. Sorry, let me shrink it back down so you can see like this. Oh, sorry. So if I do a ping dash H like this, I'm going to get the list of the common option. So if I want, like, what if I don't want to ping and send only 4 requests? I wanted to do 10 requests, right? You can do a dash R and account value. But you still have to have the destination address. You can't just ping blank, right? We have to put in the destination address, but the option, the switch is there for you to use. And so there are other options here that you can see.
So
Yeah.
a ping dash R is going to be for IPv6 only.
Right.
So
Yeah, we have to have a distinguish between version 4 and version 6. And if you read the last part here, right, you can force it to ping version 4 and version 6. But you know, for ping is a good thing. We use it for connectivity troubleshooting, but someone can use this to ping you forever, because let's think about it, right? If you know, you ever been in a car and the kid keeps saying, "Are we there yet?" Right? And the parents always have to reply. But what if there's the kid saying, "Are we there yet?" 100 times, 1,000 times, right? The parents have to respond that much. So in a Smurf attack, which is a denial of service attack, that's what happened, is you can flood a system with ping, right? And that simply is written in a script. It's a very simple script to write, actually, right? With the conditional statement, and say, if the system is connected, send this many requests, right? And so in that case, sometime that you would see firewall blocking ping over a certain number of requests. So if I was to configure a firewall, anything above 50 is suspicious, or even less, maybe 20, depending on the administrator, right? Because why would you need to ping me 50 times, right? Does that make sense? I mean, less than 10, doable. Most Windows, 4 times, 4 requests is adequate. So if someone is pinging me 500 times, that should be blocked right away and take that traffic and be able to monitor that right away, right? Block and then see who's sending that, where that come from as a public IP address. What part of the world is that located in? Okay.
it's called ping of death, right?
Yeah, ping of death, which is a Smurf attack. That's been around for ages, huh? Okay, so let's go through number 11 together. Provide an appropriate answer for the following command. If I want to do ping dash n 10, right? Remember the count? My target address, which is a loopback. How many packets are sent? So instead of doing a count, which is the other option, right? We looked at that earlier. I can put in the dash n, which generates the following value to it is the 10. That's going to be the number of packets that's sent. So similar, right? Because when you do a count, it's going to send that many packets. If I set my count value as 7, it's going to send 7 packets. But I can also specify the option just for packets using the value. So the 10 right here indicates the number of packets to be sent as requests for the ping. I can also ping a certain length, right? So, and when you're looking at network sniffer, right, we can see each of these headers information, and it will tell you the packet information. So I can do a ping, and this is a lowercase l for length, not I, L, okay? And then I can specify the byte size, the length for the packet, which is in bytes, and my target IP, my destination. if you want to do a ping until it's terminated, so it's gonna keep going, right, until you tell it to stop, you're gonna do a ping dash T and then the target IP. How many packets are sent? It's gonna send as many packets until you tell it to stop, right? So each ping in Windows is 4 packets. So this is, we would do it continuously until we terminate. This is similar to what you've seen in Linux systems, right? When you do a ping and a destination in Linux, it keeps going until you cancel the process. And then if I use the switch K, ping dash K and the destination IP, I can exclude the host IP from the route list. So if I want to exclude, right, from the route list, I would specify that. Now, how can I distinguish between regular ping version 4 IP address to version 6 IP address? For Windows, you're gonna do a ping dash 6, right? That's different than count 6. We don't want to do a count 6. We want to say ping dash 6. That's gonna use version 6 address. And in Linux, you just do a ping 6, no space for Linux. Any question? So the use of these commands are important in different aspects, right? In checking your network status for the system, troubleshooting, in security aspect. We have to understand how these things work for the services. So if on a public IP side, I can definitely ping a public IP, right? You saw that I pinged Google server before. You can use it to check to see if the system is responding, right? If it's responding to that certain service. Now, from an ethical hacking standpoint, or even an attack standpoint, someone can ping and find out more to discover, right? That's the first stage in attack, is to find out who's connecting and if that system is connecting. Yeah. So the first part is to see if it's responding to your request. And then you dive a little bit deeper, do a scan, right? See what's permitted. But in an ethical aspect of it, we only do it when we're permitted, right? Written permission. You don't just start attacking people randomly. Yeah, that will land you in prison for life. So don't want to do that. Permission to attack. That's what you need. Okay. All right. So for 13, it says when you're using ping and receiving reply timeout messages, then you try to add the timeout value using option W. The whole system is returning reply. What could be wrong with the network? So you're getting request timeout or reply timeout, and then you're trying to modify some timeout value. That means that your packet is arriving, but it is delayed or slow. That means that we have latency in our bandwidth. So let's think of it this way, right? You want to see how many cars are exiting from the freeway, right? Let's say 1 car per second. Normally, that's the case. It's as every time that they exit, it replies to your request, right? are you exiting? And it says, yes, I'm exiting. But let's say that there's a congestion on the freeway, there's an accident, something happens on the freeway. Each car is gonna exit every 5 seconds. Now, in the system environment, when it's outside of that timeout window, right, it's not gonna respond. Okay, so that's why you're gonna get timeout there. But if you modify the option saying that you're gonna give it a little bit more time to reply, and it's replying, that means that you have congestion in your network, latency. And that could be a physical thing, that could be many other things. That could be something is, a lot of things are broadcasting, right? And you know, if everybody's using bandwidth to send noises to everybody else, yeah, that's gonna absorb most of your bandwidth. So we then need to narrow down where that problem is gonna be, right? Like which lane has an accident? Why is it everybody exiting properly, right? So in that aspect, we have to really look at the health of our network and how that, you know, how the latency occurs. Okay. We spend a lot on ICMP because this is important for various reasons. Okay, what type of ICMP messages is used for echo request and echo reply? You would, so you can do an echo request. It's gonna use the numerical value is 8. This is considered a request value. So when you see that, you see ICMP, right, with that value, that means that that's a request. And then the echo reply, it used the value 0. That indicates that it is a response or reply. Now you can test this, right? You can run Wireshark and then let it run for a few seconds and then open up command prompt and start pinging yourself multiple times. But don't close it right away, right? Let Wireshark run again because you know there's a delay for maybe a minute in and then stop the capture. Open up the capture and look at the packets. You see the request and the reply. That's the best way to really logically see it from a software standpoint. Okay. And then if you want to follow all the packets, just do the follow the conversation, right? I show you how you can do that. The best way to learn network traffic is through Sniffer. That's going to give you a big picture of what things look like coming through the network, who's talking. And, you know, it helps with the visual because a lot of these things you're like, oh, how am I going to know the difference between this and that, right? The type of communication, who's talking and what type of service it's using. Sniffer is going to show you all of that. And Sniffer is important in, you know, the network administration and also the cybersecurity aspect too. We use it for, you know, network defense, but also for purple and red team area as well. Okay, let's move 15 down. We're good with 14. Any questions? Okay. What command is used to send a custom packets to the host using TCP? And I can use hping2. This is a really important tool from an ethical hacking standpoint, but also, you know, if you want to customize your packets. Normally we customize the packet for security reasons. You can use hping2. More friendly in the Linux environment, right? But definitely used in command line in different platforms. So the routers mostly handle, right, the traffic from networks to networks. It's kind of like the router gets you to the exit, right? The switch gets you to the street in your town. So the router is going to bring you to the traffic to the network, the destination network. And then from there, the switch is going to handle how it's going to bring it down to the segment, and then using, right, ARP information, it's going to then narrow down to which computer on which segment. Like, why is it different here than Norco College or RCC, right? It's still coming into the RCCD network. Well, all of that is going to be branching out to segment from the switch level, but the router is going to handle that. So that means that if you want to determine how many networks or routers that handle your traffic, let's say that I need to know from here to maybe YouTube or social media like Instagram, you know, how many networks that my traffic has crossed over, how many routers have passed my traffic. I can do a trace route. You would do trace RT in Windows, and then trace route forward in Linux. Let's try it. I think I've had you guys tried it before.
I think we did this last class, and it does, it shows you how many jumps, basically.
So my challenge for you is, can I just trace route a domain name? Try that. Like youtube.com. Can I? I know I can do an IP address, correct? So can I do trace RT YouTube, sorry, .com? Can I do that? So if it's allowed, my question for you is, who handles the youtube.com to an IP address? That's your DNS, right? So ultimately, I'm following the traffic to youtube.com, which has a web server that's tied to a DNS, right? So it resolves it by an IP address. You see that? Do you see how DNS works now? So it's going to say, oh, hey, youtube.com is associated with this public IP, which is listed right there, right? Now, Windows is going to tell you that it's maximum 30 hops. Is it necessarily 30 hops, more or less? Sometimes a lot more, right? Sometimes less, depending on your destination. So if I'm following it, you can see that it's leaving our local network and then eventually entering other service provider network, right? So I would be able to see the routers. You see, starting with the .1, that's your gateway, right? And then alternate and other routers that handle with it. So when you do a trace route, you basically following that traffic, like putting that camera on that packet, and then see who passes your traffic from here to your destination. So you can definitely do an IP address for sure, but you can resolve it with a name as well. Okay. Now this is gonna be slower than your regular. Like if I just type in youtube.com on my browser, it doesn't take this long to load the page, correct? Unless something's wrong with their server. It's because you sending it uses ICMP as well. You're sending a request, and then you have to reply to the router saying, hey, did you receive my packet? And then it's gonna say, yes, I am this router and I received the packet. So you got the report for one, and then the next one and the next one. So there's request and reply every single time for the trace route. Okay, does that make sense? Any question?
So instead of a straight shot to YouTube, it's like it's doing a shuttle run going back and forth.
Yeah, it's gonna say, you know, traffic received by, and then the router says this is my IP address. And then, you know, and then it passes to the next one. So each router has to report back to you because each router was being requested with that information. Give me the report. Who receives my traffic, right? Okay. So if you want to speed this up, how can we manipulate this? And so the only way that you can speed up the process is to eliminate some of the criteria. Okay. We can't really speed up how fast the system is going to respond to us, but we can say display less, give me less information so it respond a little bit quicker. You can do a trace route -D, which is going to eliminate some host name information. So we see that, right? A lot of times it's going to report back with the addresses, but sometimes it will report back with some system host name information. I think this, you need to eliminate the W. I'm sorry. I might have written this in a rush manner. I don't think you need to put World Wide Web on there. So if we want to trace Google over a certain number of hops, because we could say that ultimately it might be more than 20, it might be 40 or 50, but the Windows is only going to give you 30 hop report. You can do a trace route, and if you do a -H with the value, which is the number of routers, that's going to report back, and then your destination, and definitely be able to use the IP here, right? I only put google.com is because that was in the question. But if you know a certain Google server, because google.com can resolve in various servers, they have many. So if you have, most of the time you would see the one for Los Angeles because that's for the closest location to us based on our internet service provider traffic that was sent. But you can, if you know like Google address, you can plug that here.
For 19, shouldn't it be 496.4?
Yeah, that's right. And you can eliminate the W as well. So if you, I'm going to highlight right here. Technically, you need to put in the version 6 address right here. Okay. So who knows how to find public IP? I said this before. How can I find certain entity public IP? Hmm? Yeah, but with what tool? Who is? Oh, I lost my share somehow. Oh, I'm just opening this, expanding it. Let me open a tab. So you can simply go who is. Now, sometimes they hide this information. So who is gives you the lookup for all the registered domain that exists. Well, it doesn't always give you that, but I can manage it. So, if let's say that I want to have a website, and I pay the service provider, let's say GoDaddy, a certain amount of money to have my website. GoDaddy is then gonna give me the registered IP, public IP address to my website. Now some company like Facebook, Instagram, you name it, some of the social media, they choose to hide their registered public IP address. And then, in the case that someone might scan against it, can you find that out? You can, if you dig far enough. There are tools that we can also find. But if you search for who is, the first thing that's going to come up is ipconfig. That's the original tool. But there are other providers that's going to allow you to look up like IP addresses, right? Like if I go here and I go google.com, you just type in the domain and then you can tell yourself sometime, yeah, like this. But So it tells you a little bit about, you know, their servers. They do have address blocks, and this is one of their blocks. They have many blocks, right? So it will tell you that this is for the location. And then they have blocks for, like, you know, Los Angeles and other part of the world. And so this is how you can find information about public servers. Okay. For 20, what information is provided by netstat command? We saw a little bit of netstat earlier. You're gonna get the protocol type, like HTTPS, your local address, your port information, your remote address, which is your, you know, if I'm connecting to Google, right, the remote address is gonna be the destination address, and how I connect with the port. And then the current state, establish, right? Time wait, close time, etc. So netstat is going to give you the protocol which speaks to the service that's being used for the connection. My local address, which is my IP address in that local area network, that's a private IP. The port that I use for connection, the destination address, who I'm connecting to, and the port that I use to connect to that machine. Because you're gonna have the source port and the destination port, right? We talked about that when we looked at the HTTP traffic last time on Wireshark, and whether I was successful in establish the connection or not. Now, if you want statistic information, you can add the switch or the option S. That's going to give you the statistic from your network adapter or whatever adapter that you would use to connect. Now, you know that traffic is going to be UDP and TCP depending on the service that I use. So if I'm using HTTPS, that will be umbrella under TCP. But what if you only want to display UDP, right? User Datagram Protocol, like DNS uses UDP. There are a lot of different services that use UDP connection. So you would do a command netstat with an option P for protocol, and then you specify your protocol suite, your TCP or UDP. By default, it's going to be both, okay? Depending on whatever connection and service that you use. Sometimes I might only be on TCP, right? Or both. So if you want to kind of narrow down or filter, you can put in the option protocol and then specify your UDP.
Number 22, that's supposed to be netstat.
Yeah. Oh yeah, I'm sorry. I have a typo. Netstat. Good catch. Netstat-P UDP. So I remember long ago when I was teaching bachelor level classes, and I always harped to them about, don't use telnet, don't use telnet, it's not secure, right? And then one day I had asked them, do you know how to connect via telnet? And nobody knows, right? So it's just sometimes theoretically we might assume that the students or people would know. But so I added this question because we talked about telnet. Well, even though we don't use telnet, I want you to know how it's used. Down the line, when you connect terminally to the switch or the routers, you would be able to use SSH. But for telnet, you can open a command prompt or command line. In Windows, you would use telnet.exe. In Linux, terminal, I should say, you use I can't type today. Telnet command with target IP. Like telnet 10.0.0.1, right? Yeah, you gotta tell it which system that you're connecting to. And then if it's successful connecting, right? I tested this with my class the other day. So when you do telnet and then the target system and it's successful, it's just gonna say, oh, it's successfully connecting. And then the whole point in telnetting is you connecting that system remotely and do something with it, right? Like if I can terminally connect it to your system via command line, well, I can execute command on your computer to do something. That's how it's like remote desktop, but in a sense where everything is not secured in plain text in the traffic, and also I can connect to your command line and be able to run, I don't know, executables, malware, add files, change your put some obscene picture on your desktop. So all right. So what part is used by Telnet? 23. And I always remember the SSHs. You guys know the port number? 22. So in following is 23. FTP is 21. Secure FTP is 22, the same port as SSH. And Telnet, which is almost in the same line of service, but less secure, is 23. It's after SSH.
You think it would be smart to get all the ports added on me so I can
Now, oh, right here. Every time you look at the mirror.
I think you have to do it flips though, you can actually look at it.
Yeah, backwards. I'll come to you eventually. If we repeat it enough and we see it enough, right? We use it enough, you remember. So the next part talks about FTP, file transfer protocol. There are still FTP servers that are used, right? So Mozilla provide FTP servers. There are, you know, a lot of the times you see secure FTP servers. That means that you can't just go in and as a guest or anonymous user and be able to download things. You have to log in, authenticate, right? Create a user account, authenticate, and then be able to download files. But FTP servers basically provides a repository where people can upload and download files to share. So there are two modes that can be used for file transfer protocol. Text-based only that uses ASCII file, right? And then executable files, which is considered binary. So as some of you might have learned programming before, right? When you compile, you can create a bin file, but binary file, be able to distribute that, and that's considered a non-ASCII file. Okay, so there's two categories, either it's text-based or non-text-based, and the non-text-based can be executable. Can FTP server have malicious files? Sure, right? If it's not properly managed, it can be a way to distribute infection or infected files, and so on. So when you're using regular FTP server, it's really hard to track who's uploading, you know, infected files or bad files. So when you're using secure transfer protocol And with authentication, we try to stay away with anonymous. So that's one area when you are assessing FTP is to see what kind of service FTP is implemented. And all of these servers, they always have banners, which contains like server configuration information and so on. So how do you connect to FTP server, right? You would use FTP command and the server IP address. Or you can use the .com, .net, etc., right? The fully qualified domain name. So you can use lowercase FTP, and then the IP address for the server, or FTP, and then the blah, blah, blah.com, or .net, or .io, etc. So now we know how to connect, right? In terminal, you only need command line for most things these days, so. Okay. I'll move 26 down so we can see both in case you're still working on that. Okay, for 27, list the FTP command for the following criteria. Automatically log into anonymous account. I can use FTP-A. A stands for anonymous. So when you set up the FTP server, you can enable anonymous account. That just means anyone can go in and use that account. So they can just click anonymous login, and usually sometimes they don't even have a password, and if they do, it's really simple, right? It might have been shared also with the server provider. So you can do an FTP-A. You can also disable automatically log in by using a -N. So when you look at a vulnerability in your infrastructure, if you have an FTP, we want to get rid of this. Okay. So if you run this and you're successful, that's a vulnerability, right? Okay, 28. What type of servers allow you to back up router configuration, Cisco networking operating system, like your ISO? That's like just the OS for your Cisco appliances to work. It's embedded Linux. And device configuration. That's going to be your TFTP servers. These are used to store system configuration or backup system configuration in case your configuration gets corrupted. You would be able to pull them, right? We have other form, there are databases that we use, and you would be able to have like images, configuration file, and associate it with a certain system. So you can quickly find it. So it doesn't have to be TFTP server. It can also be database. I prefer database because inventory and report is a little bit easier. However, there are console on FTP servers for management that you should be able to manage your configuration files. So basically, these are configuration files and images that you would store, and you can distribute it across your network this way. So if you have a lot of branches and locations or data centers, you can have these servers up to be able to store them for backup use. 29. What command is used to query DNS server? Not the local DNS client cache, right? To clarify. For specific type of records that can be used for troubleshooting why the system cannot connect to another remote system, especially the NS system, you can do nslookup. right? The keyword is query a DNS server. So nslookup. We saw that earlier. Almost done. For 30, what command can you use to gather a summarized information about the IP address of a fully qualified domain name like the .com? Provide an example. I can do a dig command, and then you would follow that up with the FQDN, which is www.ebay.com. And you can either shorten it or, make it verbose. Because if you don't add the short, it will be verbose. That means it has a lot of text in the output. So dig. And this can be part of what your discovery process, right? I know some of you are interested in ethical hacking. So dig. So if you go to, what page is it? 9. There are variations of dig command and how you can use, right? I put in some information for you there. We talked about host name. You can find the computer name. You can also use host to find server information like mail server. So you can do a host with dig or an nslookup command. So when you do a dig command with other, right? Other command, you can also find additional information. Or you can use the command by itself as well. Okay. So for 31, identify the utility for the following criteria. Identify specific servers on the network. You're going to do a host command. If you want to send multiple ping messages to each router between the source and the destination, remember that like when we did the trace route, right? Like it query each of the router, but in the case if you want to do ping messages for each of the router from here to the destination, you're going to do an MTR. And then if you use a route, and you don't have to do this on the router, you can do it on the system. The system actually has a routing table information because that's how it's able to revert back to that stored information for the same traffic that's connected to, let's say, a website, a certain web server or a domain. And if you don't believe me, go back to command line and we would type in Claire. Right? Can do a route. And then it would tell you, in order to see your route, you would do a route print, and then you can do other extension with it. Okay. But if you just do the command by itself, it tells you that you can use these options. Okay. So we can do an add, we can force IP version 4 or version 6 for the route. So all that is if we do a route print, that's going to give us the routing table that our system stored, right? It doesn't have to be a router, but if you do it on the router, Depending on the router, if it's Cisco, then you have to use Cisco command. But when you do a route like this, it just specify. Now, can I set a static route for a certain system or a certain router? You sure can, right? But most of the things we use are dynamically routing. That means that whichever router is available is gonna handle it, right? Okay, for 32, last one, then we do the break. What should you do to troubleshoot name resolution protocol on the network? And this is important, right? This could be your interview questions. They would ask you, oh, you turn on the computer, you open the browser, and you're trying to visit a website, and it tells you domain cannot be resolved, right? You see error, domain cannot be resolved, unreachable. It's gonna say, what do? This is what you do. You check your system information. Number one, look at your host name, your system, your DNS, do DNS lookup. Verify if there's WINS connection, if there's host files, but I would start with nslookup. And then do a ipconfig DNS flush from a client side, right? But for the server side, we want to see how they are being seen by other server and the roles that they hold, right? So it's important about your server name, the roles that they hold, your WINS and your DNS, the host files, and the LM host files. These are used for the servers to be able to provide response. Looking at broadcasts, are there too many systems being noisy with the broadcast? And in the case of broadcast, that can also prevent you from resolving the proper name. And then check your NetBIOS cache. And this comes back to the earlier question, NBT stat, right? That's important. So the key word here is troubleshooting name resolution. Name resolution pertain to NetBIOS and these guys. So how the system is identified in your network, right? And how other systems see it as an identification as name on the network. Okay. So make sure that when we have time, go through the notes, practice the command. Like I said, we're gonna do a lab 1 round, and you might have a few quiz questions in final exam. And then when it comes time for you to work, you gotta make sure. I want to mention path ping. This is important. I think it's important in troubleshooting and security. You can use this to look at network latency, right? It's still a form of ping, but it's also going to give you the path that's used to get to your destination. So it's a little bit more information that's going to help you see how, your traffic going from source to destination. So, and then, so we use that for troubleshooting, but also for discovering the network. Okay. Now, when you're resolving network issues, refer to this section. Check your IP. Ping, right? Clear your cache. Verify your router, your default gateway. Trace it. Check your ports. And these are some of the main things you should do. Okay, Network Plus will ask you that. They love asking troubleshooting questions. Okay. So there was a question in the last session about your network certifications and, so in the next couple of weeks, I will set up emails to go to each one of you with your test out access, and you can activate your test out on the website, you will have to do a practice exam for this class as part of your grade, but definitely use test out. You have a year now. They narrow it down to a year to use it. And then if you are part of MVC apprenticeship, we can give you Network Plus voucher when you're ready to take the test. I highly recommend doing tests out along with studying other sources, like using a practice book. You can get exam cram for like $10. You can study it. Yeah, Professor Messer, you can follow him or pay for his service. You can use there are a lot of different resources, but I will see if my former student had sent me study guide for Network Plus, but I think some of them just passed it, so I don't think they created study guide for it yet. Yeah, there are a lot of different resources that you can use, but I would recommend spending a little bit more time studying it for it compared to Security Plus. It is a little harder as a test, as an exam. It's highly demanded in IT and security. Even though a lot of companies would just only list Security Plus, but having a Network Plus, because ultimately all of the security things come down to network services. Okay, whether you're looking at applications or just malware or all the areas, it comes back to system and networks. Okay, I'm gonna stop recording. I'll let you take a break.